One of the main goals of this project is to have a zero energy balance, and that means that we're producing the exact amount of energy that we're consuming. And obviously it's not going to be exact, but we want to get as close to zero as we can.
The most exciting thing is our relationship with Habitat for Humanity, and that it's going to a real family on a real site as soon as the competition's over.
This is truly a multidisciplinary venture. So we have engineering students from mechanical engineering, civil engineering, electrical engineering, all working together with their design student counterparts and merging technologies and design.
It is really deeply cross-disciplinary project across a whole range of social science activities, engineering activities, design activities into an overall project that is far more than any one individual group could bring to it alone.
Within this house, we've worked really hard to achieve a zero energy balance by having a very tight envelope. It's very energy efficient and has very green materials and really high quality of life standards. Almost everything inside does multiple duties, and so, for example, we have a staircase that hosts all the closets, and we have things like a kitchen island that can double as the dining room table.
Every part of the house works together. There's the PV on the roof providing us with all the energy we need. In addition to that, all of our units, including the ERV, the mini split heat pump, will be connected to the control system.
In designing this house to be net zero energy, I have had three primary roles. The first is designing the windows, both in their locations and in their building construction methods. Also, I've been very involved with the building assembly, the walls, and how they're insulated and constructed. And then also with interfacing with the engineering students on the energy modeling.
This house it's very unique compared to other houses because it's got a lot of monitoring systems, a lot of building management built into it. We're collecting tons of data. All of our energy is being monitored. We're going to be able to tell how much energy the house is using. We have a building management system which will control different functions like the lights in the house or the thermostat set point. It's all being controlled wirelessly. We also have energy production. We have a PV array. We have 16 modules up on the roof, and then we're going to actually add 4 more modules on the roof when we move the house towards 7.
We decided to divide the house into a wet module and a dry module, keeping all of the plumbing and mechanical on one side of the house, and then the dry spaces, the bedroom, living room, on the other side of the house. And then what we're doing is bringing those two sides of the house together, allowing for an access corridor in between from the front to the back of the home.
We decided to do a panelized construction of this house. We decided to experiment with a modular sort of off-site construction technique, which allowed us to fabricate the primary components here in the shop. We used Nordic I-beams, which are traditionally used for floors. We actually used them for the walls as well. It gave us a super deep cavity within which we could fill with our dense pack insulations. We're using a blown-in cellulose insulation. It's dense packed, which means that it's blown into the cavities, and it gives us a very tight air seal.
We're building this house according to Passive House standards. It's the most rigid energy standard in the world. So you have to pay very close attention to energy losses and gains, losses through cracks, solar gains through windows, and we take all this into account when we're designing the house, and that's how we interface with the architects as far as the design.
Our house is actually oriented 90 degrees from what you would typically orient a house for optimal solar heat gain. The windows that we have are amazingly well sealed. There's triple gaskets, so when you close it, there's absolutely no air leakage through.
We put a lot of effort into making this energy efficient and also to conserve as much water as possible. We used 3 different methods. One was recycling our grey water, rainwater retention, and also by using water-efficient fixtures. We're using a small device that will be underneath the sink that will collect water from the sink and then filter it, clean it, and use it to flush our toilets. And that way we save a lot of water that way.
As a team, we are trying to understand the investment of the passive house. We're trying to look at tomorrow's savings in terms of today's higher costs.
Our preliminary result from the analysis is that the return on the investment is going to be in about 10 years.
First and foremost, I'm part of the team that's designing the interior of the house. We've tried to use things that are recycled, that are low VOC, but then also too, things that we're able to get sponsored and donated to us as well.
I'm working with the Milano School on community development in the family selection process. We're looking for people that have a loving relationship and that really do care about sharing and spreading this message, and also the positive effects that it has on the environment and on the community.
We've been working on a number of projects for the house, mainly the modular furniture for the house as well as lighting fixtures. Basically modular furniture that can be used to create different storage spaces. This is a desk lamp that's primarily solar powered, so it has no cord. You can just remove this component and keep it out in the sun for a couple of hours and put it back in and it will light up.
The fashion department has two roles in the project. The first one is to supply the house with a wardrobe, and the second is to design the outfit that the team would be wearing on the mall while presenting the Empowerhouse. The way we're reflecting with the net zero energy is with the zero waste pattern. So there's literally nothing left over and you use everything.
To me, it's been a great learning experience. It's been a great way in which I can contribute to society, and by bringing these new technologies that exist to light and showing how efficient they can be.
I became an architect so I could make a tangible difference in how we treat our environment, and this project has really been the realization of that process.